Dan Perry here with another digital electronics tutorial for Dan on Tech. In this video we will learn how to do binary to decimal conversion. In the last video we did decimal to binary. Now we're going the other way, and once again you need those powers of 2, and I'm just going to write them here on the side: 128, 64, 32, 16, 8, 4, 2, and 1. And if I have a binary number, and here's a binary number, what I do basically here is do a series of additions based on those powers. So the first number here, that's in the 8th or the first place here, that was the 2 to the 7th place. That's the placeholder for the decimal 128. So I write down the 128. And then there's a 0 in the next one, that's the 64 position. There's a 1 in the 32 position, so write down the 32. And there's a 1 in the 16, so write down the 16. There's 0 in the 8, but there's 1 in the 4 and the 2, so I'll write the 4 and the 2 down, and a 0 in the 1's position. So I write those down and then add them, and assuming I add correctly, here we've got 8 and 2 is 10, plus 6 and 4, that's another 10, that's 22, so bring down a 2, we've got a carry of 2, so 2 and 2 is 4, and 3 is 7, and 1 is 8, and then our 1 here, so I wrote so 182 would be our answer. Okay, let's do another one, and with this one, let's go ahead and let's just erase part of this and see if we can do it that way. Now, you can see all you're doing is figuring out what the power position is, or what the position is for those numbers, and then you're doing a series of repeated or additions where so if I had 0, 1, 1, 0, 1, 0, 1, 1 this time. Now there's the zeros in the 128 position, there's a 1 in the 64, there's a 1 in the 32, there's 0 in the 16, so I don't bring it down. There is 1 in the 8 position, 0 in the 4, but there's 1 in the 2 and a 1 in the 1 position. And so now if I add those up, well, I've got 6 and 8 is 14, and 2 is 16, and 1 is a 17, so 7. And I carry the 1, so 6 and 1 is 7, and 3 is 0 with a carry. Bring the carry down, and we have 107. So you can see going from a binary number to a decimal number is actually very quick and very easy to do. And let's just do one more for good measure. And using those powers of 2, and you can see here while writing down when you're learning, those powers of 2 can make things go so much faster and having them. Let's go 1, 0, 0, 1, 0, 0, 1, 1. Now, something to, as a little check of your work, if you look at the least significant bit here, if that's a 1, then our answer will have to be an odd number. If that's a 0, our answer has to be an even number. But we come in here and we've got our 1 here in the 128 position. We've got nothing in the 64 or 32, but we do have in the 16. Nothing in the 8 and 4, but in the 2 and the 1 position we have 1s. So we bring down the 2 and the 1, and we've got 17 if I have added that right. So carry our 1, so a 4, and that gives us 147. Well, if we want to check our work, we can check it by going the other way. Remember, we take the number 147 and we do a series of subtractions. Well, that will go into the 128. So we bring over a 1. And Well, that's a 9. Borrow 1 gives us a 3 minus 2 gives us a 1 for 19. Well, so we had a 1 in the 128, nothing in the 64, nothing in the 32, excuse me, 1 in the 16. So we bring down the 16. That gives me a 3. So nothing in the 8, nothing in the 4, but a 1 in the 2. Bring down the 1, so a 1 in the 1, and they do match. So we were able to check our work that way. So that's how we do binary to decimal conversions. And once you've got these powers down, you can find that converting in either direction is a very quick and easy process. Well, I'd like to thank you again for watching this Dan on Tech video, and please subscribe to this playlist so you don't miss future episodes, and please check out and subscribe to our other playlists on the Dan on Tech channel. Thank you.